morning, friends. I am Professor a.k.chaubey. Today again presenting you some problems of physics under the heading Physics Made Simplest. These are for CBSE courses, maybe for a medical test, for the engineering test, that is the NEET examination, CBSE courses. So let us have some problems today. The problems, let me write some small problems, say on disintegration that is the decay, on disintegration of one atom of uranium-238, on disintegration of one atom of uranium-238. One atom, when one atom disintegrates, well, what we get? The energy obtained is that is the fission, is about 200 MeV. When one atom disintegrates, the energy released is about 200 MeV. The power obtained in a reactor is 1000 kilowatt. The power obtained in a reactor is about 1000 kilowatt. 1000 kilowatt. How many atoms are disintegrated per second? How many atoms are disintegrated per second? So per second, that is how many atoms converted into energy. Energy released per atom is 200 MeV. So, and what is the decay in mass per hour? What is the decay in mass per hour? It means in 1 hour, how much mass of the uranium converted into in 1 hour? How much mass? So let us do this problem. So what is the power? P is equal to 1000 kilowatt. 1000 kilowatt means 1000 into 10 to the power 3 watt. This means in terms of you can write watt as joules per second. So 10 to the power 6 joules per second. This you can convert power into our energy units. How much? This is a 10 to the power 6. If we convert into EV or MEV, we have to divide this by the conversion ratio, that is 1.6 into 10 to the power 19 minus 19, and this converted into unit energy will be now joules EB per second. So you get this power. How much power? Power you calculate, this will be around 6.5 you divide this, so 6.25 and 10 to power 18 MeV per second. You 10 to power 19 and 10 to power 6. So you this is EV and this is MeV. So you 10 to power 6 will go into MeV. So this is the power per second. How much power is produced in 1 second? 10 to power 18 MeV. Okay. Now the energy released per atom. Energy released per atom is 200 MeV. And this is in 1 second how much energy released? This much. Because reactor power is this. So how many atoms disintegrate? From this you can find out. The number of atoms disintegrated per second. Number of atoms disintegrated per second. How many atoms? How you calculate this? So how many atoms? Because one atom gives 200 MeV. You have your energy this much, 6.25. So from this you get the how many atoms disintegrate to give so much energy. That will give you the number of atoms. So how many atoms you will get from this? How many atoms per second disintegrate? That you will get 6 point, that is the number of atoms, n. This will be 6.25 into 10 to power 18 divided by 200 MeV, because 200 MeV per atom. So this gives number of atoms 3.125 into 10 to power 16 per second. So many atoms per second disintegrate to give this much energy. Now energy released per second is say 10 to power 6 joules. Here we have previous to this 10 to the power 6 joules. In 1 second, so much energy released. Now we have energy released per hour, and energy released per hour, how much? In 1 hour. That is, you multiply by the time. So that is 10 to the power 6 into 60 seconds, then minutes, so hour, and this gives you the energy per hour. Now what is the mass? Mass delta M is how much? E over C square. So E over C square. E is 10 to the power 6 into 60 into 60. This is the energy in joules, and this is in joules, and the C square means 3 into 10 to the power 8 square. So from this you get how much mass is needed for the 10 to the power 6 joules energy, that is the per second. So how much mass? You can calculate this mass required. How much mass you can calculate from this? I get after calculations 4 into 10 to the power minus 5. 4 into 10 to the power minus 5. 4 into 10 to the power minus 5 grams. So only this much amount of mass. 4 into 10 to the power minus 5 grams. So much small mass is needed for energy per hour. This much energy per hour. So this much mass required. Only this much mass. Very small mass needed. Like this way, we should do some more problems on different topics. Because the examinations or the papers are on the question based only. So we will discuss sometimes some topic or theory also. And then more we will do problems. So theory, one day we will discuss theory and then problem. Okay. Now let us have some other problem on some other topic. Say we have one problem, say in the process of nuclear fission, that is the energy production, in the process of nuclear fission of 1 gram uranium, if 1 gram of uranium is fissioned, what we get? The mass lost is in the process of nuclear fission of 1 gram uranium. 1 gram uranium when this is fission, what we get? 1 gram of uranium fissioning gives you, say, mass lost is 0.92 milligram only. Okay? The efficiency of powerhouse run by the fission reactor is 10%. The reactor efficiency is 10%. So to obtain 400 megawatt power, to obtain 400 megawatt power, 400 megawatt power, to obtain 400 megawatt power from the powerhouse, how much uranium will be required per hour? How much uranium will be required per hour? That is the problem. That in the process of nuclear fission of 1 gram uranium, the mass lost is only 0.92 milligram, and the reactor efficiency means 10%. 10% power converted. That is to obtain 400 megawatt power, how much uranium will be needed? So that is the question. Now how to do this? Say we can do this. Say the power 400 megawatt is per hour. So how much power energy obtained? energy obtained per hour. How much? Energy obtained per hour, this will be 400 megawatt into time, how much? 1 hour. So that is simply, you convert into seconds. So 400 mega means 10 to the power 6 watt into 1 hour means 60 into 60 seconds. That means this becomes 144. 144 into 10 to the power 10 joules. So this is the power. Okay. Now only 10% output is utilized. Only 10% efficiency. That means the total energy is this. Of this, only 10% is utilized. So that means how much energy out of this 10%? So this will be how much energy utilized. E will be now simply, therefore, utilized. E utilized. How much energy utilized? This 144 into 10 to the power 10, and only 10% out of 100. So this becomes 144 into 10 to the power 10, 12, 10 to the power 11. This much power is utilized, joules. Only this much power, because 10%. So what do you get? Only 10% power is utilized. So this is power. The energy obtained from a mass loss delta m kilogram. The energy from delta m mass is delta m c square, and that this is how much? 144 into 10 to the power 11 in 1 hour. That means delta m is equal to 144 into 10 to the power 11 divided by c square, 3 into 10 to the power 8 whole square. So now what? This will be how much? This is how much? This is the, if you calculate, this becomes 16 into 10 to the power minus 5. 16 into 10 to the power minus 5 kilogram, or that is 0.16. 16 into 10 to the power minus 5 kilogram. That is how much? 0.16 gram. Okay? Since 0.92 milligram, that is how much? 0.92 into 3. 0.92 into 10 to the power minus 3 gram. Mass is lost. Per gram. Out of 1 gram mass, this much mass is lost in the energy production. Since only this much mass is lost, what does it mean? The minimum the uranium required, how much uranium required? From this you can get 1 into this, from this 0.16, 1 into 0.16, 1 into 0.16 and divide by 0.92 into 10 to the power minus 3. That becomes 174 gram. So that is 174 gram uranium is required here to produce the power. 174 gram, only 174 gram of uranium is required. Like this way, we should try some more questions. We should do some more questions of this type. Say, I have another question. Say, what is the power of more question on what is the power of uranium-238 of 92 uranium-238? What is the power of uranium? What is the power of this reactor if it takes 30 days to use up 2 kilograms? What is the power of this reactor if it takes 30 days to use up 2 kilograms of fuel? Of fuel, and if each fission gives if each fission gives 185 MeV energy. So, what is the power of a reactor, this uranium? Take in 30 days, 2 kilograms of fuel is used. In each fission only 185 MeV energy is produced. So, what is the power of a reactor? So, you have to calculate reactor power. Means 235, well, this is the not 238 but 235 uranium. So that is 235, say atomic mass unit, we take 235 atomic mass unit of uranium, that is 1 atomic weight. This uranium gives 185 MeV energy, 185 MeV energy. Therefore, the energy given by 1 AMU Therefore, the energy given by one atomic mass, one atomic mass unit. If this much mass energy given by, therefore the energy given by this, how much you will calculate. That is the 185 is given. 185 divided by the atomic weight, 235, and that means that is the MeV. This means 185 into 10 to the power 6, that is the MeV, so 10 to the power 6, and then you can convert into joules. So that is 1.6 factor more, 1.6 into 10 to the power minus 13 for MeV conversion, divided by 235. So this will be how much? You can calculate. This will be about, okay, so you calculate. And then we know one atomic mass unit is how much mass? 1.66 into 10 to the power minus 27 kilogram. This is by definition. But one atomic mass unit is this much. So therefore energy released, the energy released is how much energy released? Therefore energy released by right here. Therefore energy released how much? 185 by 1.66 into 10 to the power minus 27 kilogram. That is one atomic mass unit. How much? This you can calculate will be 185 divided by 235, 1.6 into 10 to the power minus 13. So this is the energy released by one atomic mass unit. That is the 1.66 10 to the power minus 27 kilogram. So from what is the given mass? That is 2 kilogram. Therefore, energy released by given matter by 2 kilogram of uranium 235. This is by this much. How much? This is, so this you calculate. 185 into 1.6 10 to the power minus 13 EV divided by 235, and this mass 1.66 into 10 to the power minus 27, and here 2 kilogram. So that you calculate. This will be how much? 1.517 into 10 to the power 14 joules. Therefore, the power, this is the energy. Therefore, the power, how much power? Power means per second. That is the energy per unit time. Let us say you divide by the time. 1.517 into 10 to the power 14 and 30 days. 30 days converted to second. So that is 1.517 into 10 to the power 14 into 30 days, 24 hours, then minute, and then seconds. So this you can multiply. This becomes power. How much? 5.85 into 10 to the power 7 watt. So this is the power. Power released. Nice. Very nice. So, like this we can solve different problems based on our energy and say decay, nuclear reactions, etc., etc. So we can solve some more problems of radioactivity. We can do some problems of the lifetime, etc. So we should plan some problems of this type, and we can do some more problems of this type. So that is, so friends, do some more problems of this type. You will have practice. I will stop today here. Thank you very much for listening to me.